Hello, ladies and gentlemen. Today we're going to go ahead and discuss how to multiply and divide rational expressions. So if you're not sure what a rational expression is, please make sure to go back to the video prior to this one. So step one, multiplying rational expressions. What we're going to do is we're going to start the exact same way. We're going to factor everything that can be factored. Look for canceling either vertically or diagonally mean, again, top and bottoms. So even though it's maybe on a second fraction, you can still cancel as long as one's on top, one's on bottom. Then you multiply across numerators and denominators. If everything cancels out of the numerator, remember the numerator is 1. If everything cancels out of both, the whole solution is 1. And then again, state any restrictions. So example, factor both parts. X minus 6 is on the top here and bottom here, so they both cancel, even though they're not on the same fraction. And then simplify and state restrictions. Okay. So we're going to go ahead and ask ourselves, well, number in front. And there's something specific about the number 4. 4 is a perfect number, and so is 1. So my numerator has the difference of perfect squares. So essentially what I do is I square root both pieces. Give one a plus, one a minus. The denominator is a little bit more tricky because he has, I need to write that a lot smaller. The denominator is a little bit trickier because he has to be factored using T method. So I had that 2x plus 1 and 2x I'm going to have to put it down here. So in order to tackle him, I take 2 times negative 3, and I get a negative 6. What multiplies to negative 6 adds to negative 5? Well, 2 and 3. I need a negative. Ooh, that's not going to work. 2 and 3 are going to get me to 1, not 5. I need a negative 6 plus 1. So I have, this is still getting in the way. I'm trying to get this so I'm not in the way for the final fraction. So I guess we're going to do our work down here. So I have negative 6 plus 1. So I have 2x squared minus 6x plus x minus 3. I can take a 2x out of 2x squared and 6x, so I'm left with x minus 3. Leave a little space, x minus 3. When I end up having the exact same thing, in the middle we'll just go plus 1. So I'll have one factor of 2x plus 1, and then the other factor of x minus 3. And I'm going to wait until I do the other fraction before I start canceling because I don't want to forget. That's going to be multiplied by, since on the numerator there's no number in front, I can go ahead and go straight to my 2 sets of parentheses. So x and x. What multiplies to negative 9 adds to negative 6. I'm sorry, negative 9 and a positive negative 6. So since it's a negative and a positive, they have to both be negative, and in this case it's negative 3. And then for the bottom again, I have to do this multiplication. So 2 times negative 3 is negative 6 again. And I need to get to a positive 5 this time. So I need a 6 and a negative 1. So 2x squared plus 6x minus x minus 3. So I can take out a 2x, and I'm left with x plus 3. Leave a little space, x plus 3. This time I have to take out a negative 1. So I have 2x minus 1 and x plus 3. And I think I'm going to end up having to split this. There's no way we're going to fit the second problem. Yeah, we're going to have to just move that problem. We'll do it here when we get there, not a big deal. So let's go ahead and start canceling. I can cancel those guys out. I have a 2x minus 1 and a 2x minus 1, x minus 3 and an x minus 3. And so I'm simply left with x minus 3 over x plus 3. And we have to state our restrictions. So negative a half here, 3 here, positive a half here, and negative 3 here. Sorry, I'm cutting and pasting the problem over. All right, so same general idea. We're going to start by factoring all the pieces first. So the guy on top, again, needs to get multiplied. Hey, didn't we just have that same? This top is this denominator, which ended up turning into 2x minus 1 and x plus 3. You're probably saying, but you're cheating. I just did it. Why would I redo it? This guy doesn't have a constant, so I can only take out an x. So I'm left with x minus 4. There's no constant in this next numerator, but I can take out a 2 and I can take out an x squared. So I'll be left with x minus 4. He's good. Excuse me. And this denominator is very similar to the numerator. Here, the only difference is I have a plus 6. So it's x and x plus 3 plus 3. Because we're still multiplying to 9 and still adding to 6, but my 6 this time is positive. So I have everything factored down as best as I can. I don't have any 2x minus 1s. I do have an x plus 3 though, just one of them, only one cancels. I can cancel out the x minus 4. I'm going to break up this multiplication here. This is 2 times x times x. And if you notice, I have an x here in the denominator. So I can cross off one x and this x here. I think that's all I have left. So I have 2x times 2x minus 1 all over x plus 3. I think that's all that's left at the bottom. So let's talk about any restrictions. So x cannot be 0 because of this one. This guy causes 4. This is negative 3. And this is positive, negative 3 again, so negative 3 twice. So does it make sense to say negative 3, negative 3? No. I've already said it. No point in saying it again. I'm just going to start by cutting this problem so I don't forget to do it later. Okay, since we're doing this later, we're going to pretend he's not there. No problem. I'm just going to move it this way. Okay. So I need to take apart anything I can. I looked, no numbers in front, so that means no t factoring. That's super cool. So I can go ahead and start factoring. So the top one here, there's no constant, so I can only take out an x. The next one is got all 3 terms, so I can do my 2 sets, x and x. Okay, what goes into negative 18? Got 2 and 9. I want negative 2. Difference of perfect squares, so x minus 9 and x plus 9. Again, we have 18 but I need a negative 11, so negative 9 and negative 2. Let's go ahead and start our canceling. Those guys cross out. X plus 9 and x plus 9 cross out. These x minus 9s cross out. So it looks like all I'm left with is x over x minus 2. My restrictions are 2 here, negative 9, positive 9, and positive 2, which I already have positive 2, so I don't need it again. I didn't want to scroll down. I want to go like that. All right, I assess what's going on. I don't see any numbers in front, so I can go straight to all my 2 sets of parentheses. I identify that this is the difference of perfect squares, so yes, 2 sets. X starts every single one. Well, it multiplies to 1, adds to 2. Well, plus 1 and plus 1. Multiplies to negative 1, adds to 0, negative 1 and positive 1. What multiplies to 2, adds to 3, 2 and 1. Multiplies to 4, adds to 4, 2 and 2. Honestly, most people are probably like, wow, how are you so quick at doing this? You need to know your multiplication facts. If you don't know how to multiply into numbers, you need to seriously work on that. These are going to take forever until you work on that. And yeah, you're probably thinking, well, I don't want to work on that now. I learned it way back then. Seriously, that's the only way these are going to get easier, is knowing your multiplication skills. B, practice, practice, practice. As long as you know your multiplication skills, that's seriously where most people have an issue with these, is they don't know how to multiply. They can't do it in their head. I don't know. That's what you got to work on. All right, let's cancel. X plus 1's cancel. X plus 2's cancel. Even though I have a x plus 1 here and an x plus 1 here, they're both on top, so I can't do anything. So I'm left with x plus 1, technically squared because there's 2 of them, over x minus 1, x plus 2. X cannot be equal to, well, this one would be 1, this would be negative 1, this would be negative 2, and then this would be negative 2 again, so I'm not going to repeat myself. There's my answer. All right, that's all we got. I will see you later for your dividing.